Okay, let's look at this next problem. Which of the following statements is correct? 2 to the 5th is the same as 5 times 5. B, 7 to the 5th power equals 7 to the 5th. C, 10 squared equals this. Or D, 5 squared equals 5 times 2. Okay, take a second to look at each one of these carefully. They're in your workbook. And make a decision on which one of these is true. There's only one that's true. And we didn't make a mistake, so there's truly only one that's true. Don't make up your own choice. That would be bad. Okay. All right, let's see what you got. 2 to the 5th power means, remember, 2 is the base. So the base is raised to the 5th power means the 2 occurs 5 times as a factor. So this is not correct. This would actually be 5 squared. So that's not working out. Okay. 7 to the 5th power. 5th power means 7 raised to the 5th power. That is definitely true. Let's see why this is not true. 10 squared equals 10 to the 3rd power. Well, the 3rd power, if you remember, is another way to say cubed. So this would be 10 cubed, not 10 squared. Because it's a good idea to know why yours is correct, but it's an equally good idea to know why these are wrong. Okay, 5 squared is not 5 times 2. 5 squared is 5 times 5, because this 2 tells me to use the 5 as a factor twice. So the correct choice is B. Okay. Let's take a look at the natural numbers and the whole numbers again, because I want to review them with you before we go to the next type of numbers that we need. Okay. Remember from yesterday the natural numbers? The natural numbers start with the number 1, they go up by 1, and their symbol is an N. The whole numbers start with 0 and go up by 1. Okay? So let's answer this question. All natural numbers are whole. Okay. And we're going to answer true or false and give a counterexample if it's false. I'll explain that in a minute. All natural numbers are whole. So what they're asking me is, can you find all of these numbers, the 1, 2, 3, ... in here? Are all of these numbers in here? And that answer is yes. Every single one of these can be found in here. So this is true. Okay? Make sure you read it from left to right, because some people switch this around, and that may or may not be true. It's not the same question, so be careful about that. Okay, let's look at the second question. The second question says, all whole numbers are natural. Now, that says exactly the reverse. Okay. So all whole numbers, that means I have this set, 0, 1, and 2, ... is every one of those in the natural numbers. Let's think about this. Do all of these live in here? Well, the 1, 2, ... does, but not the 0. So that is false. Not all the whole numbers are natural. Now, it says give a counterexample if it's false. A counterexample means give an example that makes it false, that shows you it's false. Well, can you give us a number that is whole but not natural? Well, there's only one example. The example is 0. So here is your counterexample. Your counterexample is the number 0. So that's your counterexample. That's the example that makes this false, because not this number is whole, but it's not natural. Okay? Let's look at 3. I threw this in without really discussing it, but that's okay. 0 is an even number. Now, what do you think? I bet you I can guess what you think. I bet you think that 0 is neither even nor odd. Well, let's take a look at that. Let's define an even number. An even number is a number that's divisible by 2. What does divisible by 2 mean again? Divisible by 2 means that I can divide by 2 without a remainder. So 4 is divisible by 2 because I get the number 2, remainder 0. 8 is divisible by 2 because I get the number 4, remainder 0. 100 is divisible by 2 because I get a remainder of 0, kind of, right? So let's look at 0. Is 0 divisible by 2? Well, let's take a look. I'm squishing, so I'm going to redo this here. 0 divided by 2. What is 0 divided by 2? Well, if you remember what we did in a previous lesson, is anytime 0 is on top, the answer is 0. Because 0 times 2 is 0. There's the check. The remainder is 0. So 0 is divisible by 2 because it has a remainder of 0. So 0 is an even number. That is true. By the way, if you want to know the definition of an odd number is simply a number that's not even. And that's not a joke. That's truly the answer, a number that's not even. Okay, so that reviews those concepts. Let's take a look at the following. Let's get a number that will represent the following situation. A profit of $15. Sea level, a $20 decrease in price. Okay. All right, so let's take a look at this and decide what we need to do here. Well, we have a profit of $15, sea level $20 decrease in price. What are we really talking about? Well, if we want a number that represents all of them, what does sea level have to do with a number? Well, let's think about this. You know we have the natural numbers, we have the whole numbers, but there's actually another set of numbers that we haven't discussed yet. So let's do that. Okay, the next set of numbers that we haven't discussed are called the integers. The integers actually include 0. So let's just take a look here what we got. Remember, we have the natural numbers, and then the natural numbers grew, and we have the whole numbers. Now we need some negatives, so now we have something called the integers. So notice that the natural numbers live in the whole numbers, but the natural and the whole numbers live in the integers. Okay? So our sets just keep growing and growing and growing based on a need we have. Okay? Let's talk about the natural numbers, whole numbers, and the integers. When we talked about the natural numbers, we were going 1, 2, 3, but then we added the whole numbers. Now we have to add a whole new set of numbers that are actually less than 0, and that's what the integers are. So the integers -1, -2, -3, and dot, 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 -4, -5, -6. And remember, numbers to the left are getting smaller. Here's the deal. We still aren't including fractions or decimals, just whole numbers and the other side of the number line. Let's talk a little bit about that. Let's first talk about the fact that negative numbers, 0, and positive numbers. Negative numbers must have a negative with them. So if you want to show -3, you have to write a negative sign. 0 is obviously 0. 0 has no sign, it's neutral. 0 is even, like we just said, but 0 has no sign, it's neutral. Okay, so positive numbers, on the other hand, we could have a +3, we could write it with a positive, or we don't need that plus sign at all. We could just write this 3. Okay, so a positive number can be written with a sign or no sign at all. Okay, and all these sets of numbers are summarized in your workbook. But there's negative, 0, and positive. So positive numbers are greater than 0, negative numbers are below 0. So now let's talk a little bit about this number line. If I could cut this number line at 0, if I could just take a scissor and cut, and I folded, notice that 1 would fall on -1, 2 would fall on -2, 3 would fall on -3. Those numbers are called opposites. Okay, so -1 and 1, -2 and 2, -3 and 3. Those numbers are called opposites. And as you see in your workbook, it defines opposites. Two numbers that are the same distance from 0, but on the opposite side of 0 on the number line. So 1 and -1 are the same distance from 0, but on opposite sides. They're called opposites. So opposites are the same number Same number, different signs. We'll prove to you later that 0 has an opposite. The opposite of 0 is 0. Because if you actually cut, like I suggested, this on the number line, what would happen to 0? Nothing. It would stay on 0. We'll talk later mathematically how come the opposite of 0 is 0. That'll help us do these problems in a second. So the integers are made up of whole numbers and their opposites. Okay, so let's take a look back at our first example, why we had to go through all those integers. A profit of $15 means that you're making money. That's a good thing. Okay, that's not why it's positive, but actually it's above 0. That's why it's positive. So a profit of $15 is a positive 15 or just 15. You don't need the positive sign because all numbers are positive unless indicated negative. Okay, so that's up to you. C level means, well, you're not below 0 or above 0, so it is actually 0. And $20 decrease in price. A decrease in price means you're below 0. Not below 0, but you're going down. I shouldn't say below 0 because you're not going to pay less than 0 for something. Okay, but your decrease means to go down, so that's going to be indicated by a negative 20. Okay, so that's where the integers come in handy when we have to put some real situations into numbers. Okay, now let's just look at a number line, and let's see if we can figure out what number is indicated on this number line. All right, so let me put 0 in the middle. Let me put C here. Let me put B here. Let me put A here. And let's talk about what numbers these actually represent. Okay, so A, B, C. Well, obviously you can see that A and B are both negative because they're to the left of 0 or below 0. A is 1, 2, 3, 4, 5 below, so that's negative 5. Okay, B is 1, 2 below, so that is negative 2. And C is 1, 2, 3, 4 above. That makes it positive. You don't need the positive sign, but if you write it, you're fine. Okay. All right, let's take a look at another way we can use integers. In this next example, we want to indicate how many units the number is from 0, and we want to know if it's to the left or right of 0. So we're going to start with 234. And remember, you don't need that positive sign because positive numbers do not need the sign. Negative 11 and 9. And it just says 9, but that is a positive 9. So we want to know how many units that is from 0 and if it's to the left or to the right. Well, 234 is 234 units from 0. Okay? And it's to the right of 0 because it's above 0. Negative 11. Negative 11 is 11 units away from 0. Not negative 11 units, it's 11 units. How many steps do you have to go from negative 11 to get to 0? You have to step 11 steps or 11 units. 9, positive 9, is 9 units away from 0. I forgot the second half of that question. I'm going back. Hold on. Okay, so 9 is 9 units away from 0, and it is to the right of 0 because it's positive. I guess I didn't like the negative guy. Okay, negative 11 is to the left of 0 because it's negative or below 0. Okay, so that's all we want you to do there. Okay, now we want you to make your own number line and graph the following numbers. Okay, so would you graph the number 3, the number negative 4, the number 0, and the number 2, all on the same number line? Take a second to do that. We'll come back and look at it. Okay, let's take a look at the number line. Again, I'm going to put 0 somewhere in the middle. 3, 1, 2, 3. Negative 4, 1, 2, 3, 4. Negative 4. 0 is right smack in the middle, and 2 is right there. So what we have to do now is we have to just label them. So 3, because if you just have the numbers there, it doesn't mean that we're talking about those numbers, because remember, this goes on and on. 0 is right here. Negative 4 is right here. And 2 is right here. So there are your numbers on a number line, and that's how they're graphed. They're graphed with a dot. And we did that yesterday with some natural numbers, I think. Okay, now we need to compare numbers. So we're going to write each of these with a comparison symbol. And it's really a good idea, I think, for a while until you get really used to negative numbers. I think it's a really good idea to have a number line. Okay, so I'm going to draw a nice clean number line. And you're going to put comparison symbols in here. And the only ones you're using is either is less than or is greater than. Okay, so you don't have to use all the different signs. And in your workbook, you have a little question mark. That's where you're putting the comparison symbol. And the last one. Okay, I'm going to take this out so I can put my comparison symbol in. Would you do that for 1 second? And remember, as you go to the left of the number line, the numbers are actually getting smaller. Less for left. Okay? Take a concrete look at this. Oh. Okay. Negative 7 and 5. If we're comparing these, well, negative 7 is obviously negative, and 5 is actually positive. So this is really a real easy question. This is less than, because negative 7 is less than 5. Now here comes the harder one, negative 4 and negative 5. Everybody wants to say that negative 4 is less than negative 5, but let's think about this. Negative 4, let me extend my line for you. Negative 4, negative 5. Remember, as you move left, okay, the numbers are getting smaller. So negative 5 is actually smaller. Think of yourself as being more, I always think money with negatives and positives. 0 means I don't have any. 1 means I'm good. I have $1, I have $2, I have $3. Negative means I owe you money. Well, negative 4 means I only owe you $4, but negative 5 means I owe you $5. So I'm actually better off at negative 4 than I am at negative 5. So negative 4 is greater than negative 5. And notice, because negative 4 is to the right, so it's got to be bigger than negative 5. So negative 4 is greater than negative 5. 0 and 3. Well, that's not really too difficult because there's no negatives here. It only becomes difficult with negatives. 0 and 3, well, obviously 0 is less than 3. And notice you can tell on the number line because 0 is to the left of 3, so it's is less than. Negative 4 and 0, same thing. Negative 4 is less than 0 because negative 4 is to the left of 0. I'm in the hole, I'm okay. In the hole, okay. Okay, so negative 4 is less than 0. All right, now I'm going to show you something that's going to come in handy later in algebra, but I'm going to show you a little thing about a double inequality. All right. I'm going to show you how most people say it. I'm going to show you probably the better way to say it, because sometimes you say so many symbols, sometimes you say so many symbols and words that it gets distracting about what's really going on. So let me show you this. Negative 4, 3 zeros. 3, 0. Okay. Here's what I know. I know on a number line, 0 is between 3 and negative 4. Not right between, not exactly between, but it's between. So I can write 0 is between negative 4 and 3. And notice I'm putting the smaller number first. I can write this in symbols by doing this. Negative 4 is less than 0 is less than 3. You might be saying, well, why do I want to do that? I want to do that later because later this is going to be so important. Later we have an X in here, and it's called compact form. Something I want you to notice about this form. I'm putting all the inequalities left. I don't want them in the other direction. I want the smallest number first. I want them in number order. Number order. Okay, so smallest number, then this number, then this number. Okay, smallest number first. Number order, and all the inequalities pointing to the left. All is less than symbols. Watch what this says. This says negative 4 is less than 0, and 0 is less than 3. This is actually an and. This means both of these things are going on. It's called a double inequality because there's two inequalities. Negative 4 is less than 0 and 0 is less than 3. And that's true. Negative 4 is less than 0 because it's to the left, and 0 is less than 3, which is true. So that's what we want you to do. We want you to write it in this form. Okay? All right. So you try the next two. Okay, let's see how you did. Let's talk about this between stuff. Okay? Well, 8 is between 4 and 10. Again, not exactly between, not right smack in the middle, but 8 is between 4 and 10. So to write this, we can go in order, 4, 8, 10, and just go is less than. It's that simple. But I can say 4 is less than 8, which is true. 4 is less than 8. Well, I don't have a 4 and 8, but 4 is less than 8, and 8 is less than 10. Okay, or I can say 8 is between 4 and 10. That's what this form allows me to say. And when I say this form, it means the smallest number is first, okay, and all inequalities point left, and they're in number order. So that's what that form allows me to say. 8 is between 4 and 10. It's kind of cool because, again, we're going to have an X in there, and it's going to mean something to us. Right now, you're going, why do I need to do that? But trust me. Okay, so let's look at this next example. In this next example, we know that negative 2 is between negative 6 and 5. Okay, so to write that, smallest number first, I would have the negative 6, then a negative 2, then the 5. And all inequalities are going to point to the left. And notice, this form allows me to say negative 2 is between negative 6 and 5. And again, I can also say it this way. Negative 6 is less than negative 2, which is true. And negative 2 is less than 5. But it's important to say and there. And negative 2 is less than 5. And that's also true. So that's how we do that. And that's going to be really, really, really important when we have a variable in there. I know you can't wait for that. Okay, but that's really, really important. Okay, so let's take a look at the following. The next set of examples, make sure you understand this number line and the integers and how numbers are related. So let's take a look at this. Tell whether the following is true or false. And you're going to have time for a second to do these, and then we'll see how you did. They're in your workbook. Okay, let's see how you did. Negative 6 is greater than negative 11. Well, negative 6 would be out here somewhere, and negative 11 would be here. Remember, the more to the left you are, the smaller you are, so that is true. Negative 6 is greater. You're not as much in the hole either. Here you're $6 down, here you're $11 down. So this is true. 4 is less than or equal to negative 9. Well, that's easy, because 4 is a positive, 9 is a negative, so that's got to be false. Negative 8 is greater than or equal to negative 20. Think about that. Negative 8 is somewhere here. Negative 20 is somewhere way down there. But negative 8 is greater than or equal to negative 20. So that is true. Remember, you can't be both. You'll just be greater than. So that is a true statement. And the last one, number 4, I had no room for. But number 4 is the ones we just did. So you have to just decide. Notice if you see the form, all the numbers in order, smallest number first, the numbers in order, and you see the is less than symbol there in both of them. The double inequality is less than in both. You just have to make sure that 2 is between these two numbers. And they are. And it is. 2 is between negative 5 and 5, so this is a true statement. Negative 5 is less than 2, and 2 is less than 5. Okay? So this is true. Okay. It's time for some notation. Let's make sure you understand all the different notation that you're going to see. Let's look at this. The opposite of 3 is negative 3. Okay. This term opposite of, and we know this is true. The opposite of 3 is negative 3. We talked about opposites earlier. Okay. Whenever you see opposite of, that tells me that I need a negative sign. So this is the opposite of 3, and that's the same as negative 3, which obviously makes sense because this says negative 3 equals negative 3, okay? So opposite of means that negative sign. Now let's look at the opposite of negative 4. The opposite of negative 4 is 4. Okay. The opposite of tells me negative sign of negative 4. There's your negative 4. They're telling me this is 4, which we know. So the opposite of negative 4 equals 4. So what I need you to understand about this is this negative sign actually it stands for the opposite of. Negative is a really interesting little dude because this negative sign actually stands for subtraction, negative, the opposite of. Okay, and we're going to see that as we go along. But you can say, instead of saying in words, the opposite of 3 is negative 3, you can just say the opposite of 3 is negative 3. Instead of saying the opposite of negative 4 is 4, we can just say this. Okay, so this negative sign is really, really important. Stands for the opposite of, stands for subtraction, stands for a whole lot of stuff. Stands for regular negatives. Okay, so it means 3 things. It means the opposite of, negative, and subtraction. Okay, so let's take a look at this next example. Let's say I drive 10 miles in reverse. And by the way, if I'm driving 10 miles in reverse, you better get off the road because I don't really drive very well forwards. I have to tell you this story once. This happened. It's a true story. I'm in my driveway, and I'm driving out of my driveway, and I back up, and I hit the car right in my driveway. Okay? But that's not as good as this one. Ready for this one? I'm backing up, and there are 2 cars. And my friend said, no way, can you back up there? I go, oh, I can do it. I hit both cars at the same time. That was cool. Anyway, so I'd get off the road. But anyway, here's the question for you. If you drive your car 10 miles in reverse, how many miles did you drive your car? Well, did it matter if you drove in reverse or not? It doesn't matter. You still drove 10 miles. There is an actual math concept that does not care about left or right. It just really cares about the number of units you go or how far you go, and that is called absolute value. The absolute value of a number is the distance that number is from 0 on a number line. So if I want to ask you what is the absolute value of 56, now you already know a math person would never do this. There's too many words here. So the absolute value has a symbol. The symbols are straight lines, okay? This says, what is the absolute value of 56? That is so much nicer than all this. This used up way too much ink. The absolute value of 56 just looks like that. Now, what that's asking you for is, how many units is 56 from 0? It's not asking me, did I move left or right? It doesn't care. It's asking me, how many units is it from 0? So if I have a number line, it wants to know how many units 56 is away from 0, and obviously that answer is 56. So the absolute value of 56 is 56, because 56 is 56 units from 0. The absolute value of a number is not the same as the opposite of a number, okay? They're not the same thing. Let me show you why. All right, let's take a look at this. The absolute value of negative 7 asks me, if I'm at negative 7 on the number line, oh, I should go this way probably. Okay, if I'm at negative 7 on the number line, okay, how many units am I from 0? Well, I am 7 units from 0. If I'm at 0 on the number line, how many units am I from 0? Well, I'm 0 units. If I'm at 7, how many units am I from 0? I'm 7 units. That's all we're asking you to do. But let me explain it. This is not the same as the opposite of, because let's look at this. What is the opposite? I just want to prove to you what I said. What is the opposite of negative 7? Well, the opposite of negative 7 is 7. So far we're looking okay. The opposite of 0 is 0. Oh, so far I'm looking like a liar. Okay? But the opposite of 7 is not 7. It's negative 7. So absolute value and opposite is not the same thing. Okay? They are different things completely. Okay, I'm going to pose a question to you by looking at these examples. The question is the absolute value of a number always positive? Think about this before you answer, because I know what you want to say. I know what you want to jump and say. Everybody gives me the same answer real quick. But think about it. The answer is no, because look, sometimes the absolute value is 0, and 0 is not positive. What we can say is the absolute value is never negative, but we can't say it's always positive because it adds 0. So there would be a counterexample. So no, it's not always positive, but it's never negative. Okay, let's look at a little bit more notation. Okay, put the symbols into words. Oh, this is a little different. Here we go. We're going to try not to make you crazy here. We may not succeed. Okay, remember what the sign, that symbol in the front means. Okay, so let's try this. This is the opposite of -4. Okay, and if you care, that answer is 4. But that's what that says. This is the opposite of, now watch this, this is a mouthful, the opposite of the absolute value of 4. Well, the absolute value of 4 is 4, so the opposite of that is -4. You thought that was a mouthful? Watch this one. Ready? Think about what this might say. Okay, the opposite of the absolute value of -4. Well, the absolute value of -4 is 4. The opposite of that is -4. Now, to me, that is an incredible pain. That is just too much. That is just too much words for me. Too many words. I'm a math person. I don't like the words. So I'm going to show you how to get rid of the words, because I like to get rid of the words. Okay, here we go. The rule of thumb for absolute value is very simple. When I want to evaluate an absolute value, whatever symbol or sign is in front of the absolute value, I'm just going to bring down. So I'm going to take this negative and just bring it down. And then I'm just going to do the problem. The absolute value of 4 is 4. So that's the answer is -4, which is what we just said the answer was. Now here's the thing. I know what you're thinking. I just said that the absolute value of a number is never negative. I didn't lie. The absolute value of the number is 4. That negative in the front made it negative. So I didn't lie yet. Okay, here we go. I am from Brooklyn, but you have to watch that. All right. Again, we do the same thing. Bring the negative down. It's in front of the absolute value. And now we just do this. The absolute value of -4 is 4. So instead of saying all of that, the opposite of the absolute value of -4 is -4, I can just bring this down and do the absolute value of this. Same thing here, bring this down, do the absolute value. It's a little easy to deal with that way. Well, that's it for now for absolute value and integers, and next time we'll do adding integers.